So let's talk about the standard, right? Again, I wanted to show you the standard and show you how small it is, right? Very small, not much reading, very easy to go through. So I want to go through a few things about the standard so you can kind of understand where we're coming from. There's an intent, and then there's a title, purpose, and scope. So we'll go through them very simply. The intent of it is for building owners, right? As a means of specifying a defined and common scope and level of vigor for that particular building. Very simply stated, that is the whole intent of this document. The purpose is, defines the procedures required to perform energy audits in a level 1, 2, and 3, provides a common scope of work so that everybody can be doing the same scope of work, establishes consistent methods, means on how to do that, and finally, it establishes a minimum reporting requirements, so again, everybody is doing the same thing when it comes to producing that report. The standard covers all buildings, right? All buildings except mobile homes, small little apartments, small little modular homes and things like that. But for the most part, the standard covers all buildings out there that you can do anything on. So I'm not going to go through the whole standard because we don't have so much time, but I want to highlight the sections that are really important. So, Section 4 tells us that the audit shall be certified by a qualified auditor. That's important, right? Because in order to qualify for the standard, you have to make sure that you have a qualified energy auditor doing the work, right? Not anybody in the office can do that. You have to prove that you're qualified to do it in order to meet the standard. There are many procedures out there and many methodologies to make that happen. And as far as the procedures and the scopes of the systems, the scopes are very large. We go into and we talk a lot about mechanical systems, electrical systems, and building systems, right? So mechanically, pretty simple, right? Heating, ventilation, air conditioning, energy systems, outdoor air, makeup air units, etc., etc. Electrical, again, very easy. Lighting systems, power, that sort of thing. And then finally, on the equipment side, which is something that's becoming extremely popular these days, is what we call the envelope. Looking at the outside of the building, the doors, the windows, the enclosures, and making an analysis of them, because that is what allows the energy to come in and out of the building. So obviously, if you're going to do an energy audit, you need to be able to analyze that and also report on it. General procedures just talks about the role of that qualified auditor. Obviously, they want the auditor to conduct the work. They need to make sure that somebody that knows what they're doing is going out to the job and actually performing the work. As well, in section 5.2, it says the qualified energy auditor shall conduct and supervise. That means be in responsible charge of that energy audit and make sure they report all that to their customer and sign and certify that that was done. So that's really briefly some ideas about those important sections of the standard. In summary now, we're going to go through what we call level 1, level 2, and level 3 audit. There's a lot, there's pages and pages and pages to go through, but I want to summarize them for you so that you know what level of work and scope you need to be prepared to do in order to do a level 1, level 2, and level 3 audit. So first, level 1. So obviously, you have to look at the utility bills, the electric, the gas, all the means of energy that comes in and out of the building, which also, of course, includes renewables, photovoltaics, thermal storage, all kinds of those things as well. Once you do that, then you calculate what we call an EUI, right? An energy use index. You use that electrical, gas, utility information and the square meter, square foot of the building, and you make that calculation, which we call an energy use intensity. Then, what you do is you compare that to a lot of the benchmarking programs that are already out there. In the U.S., we have Energy Star, we have Building EQ, we have some DOE stuff from the government, but there's a lot of different benchmarks out there that you can compare your building to. But that's what you got to do starting at level 1. Then you have to make a site survey. You have to walk around the building, see what's going on, see where the equipment is, see what that equipment serves, right? Conference rooms, auditoriums, offices, etc., and make a list of that so we can look at it. And then we make a space function analysis. We have to go to each space, or each significant space, and write it down, say what it does, and say what HVAC and our system serves that. And then finally, in a level 1, you got to go out there and find the low cost, no cost energy conservation measures, those things that are very easy to do and don't cost much money, and report those. They're always easy to do. There's always an easy way to find the low cost, no cost alternatives. Very simple. Level 1 is not invasive, right? You don't go in there and start opening up equipment and doing anything invasive to the building. It's a simple level 1 procedure. That's it. And then finally, the qualified energy auditor has to report that to their customer, the owner, or whoever they're talking to. That's level 1. Very simple, usually takes a very minimum amount of time. So when you progress to level 2, you go through all the level 1 stuff that you just did, and now you add to it. You have to make an energy cost component breakdown. You have to make a more detailed facility group tour. And now you're going to start looking at how does the customer take care of their building? How do they operate it? And how do they maintain it? And you, the qualified energy auditor, have to look at that process and those procedures and critique them and tell the customer how they can do that better. Because there's always room for improvement, right? So you have to tell them what that is to improve. Then you determine what the key operating parameters for the building is, like temperature set points, humidity set points, any kind of building pressurization levels, etc., etc. Obviously, you're going to go into the automatic temperature control system, building automation system, look at it, critique it, and make sure that it's working fine as you go through your level 2 audit. You're going to make a qualitative analysis of how their cooling is being used. How's their heating being used? How do they pressurize the building? What about their lighting system? Do they work? Are they new? Are they old? Do they need to be replaced? Etc., etc. You're going to have to go through there and critique that as a level 2. And then you're going to have to perform some economic analysis, right? So we have a lot of those to choose from. Level 2 is kind of like a middle level, and so you can use a lot of the most common economic analysis types, and we'll go through those in a little while, but you have to give the owner, the customer, the value of the energy conservation measures that you are suggesting, how much they'll cost, how much they'll save, and roughly what is their payback as time goes on. And of course, when you're done with all that, you have to go to the owner, sit down with them. You, the qualified energy auditor, sits down with the customer and explains to them what's going on. Now level 3. Level 3 is not something that we do a lot of, right? As an energy auditor. As an energy auditor, it's really rare to go into a level 3 energy audit because you have to go do level 1, level 2, and then when you get into level 3, you got to start doing a lot of engineering type analysis. And typically, that's what a consulting engineer does. So anytime an energy auditor goes into a level 3, my suggestion would be always to hire a consulting engineer so they can help you do that, because your expertise may be in energy auditing, but you're going to have to bring a lot more expertise to the table when you do a level 3. The engineering work is huge, and then on top of that, you have to start doing a more detailed cost analysis, right? So before, in a level 1 and 2, you could do easy stuff, right? First cost, last cost, how much you save, easy stuff, present worth analysis. But for level 3, now you have to go life cycle cost analysis, and that's a lot more complicated in order to do your work. As always, the qualified energy auditor is the person that sits down with the end customer, the end owner, and explains all this with their team. Perhaps he would bring his team, he or she would bring his team with it, but the qualified energy auditor needs to do that work in order to qualify for the ASHRAE standard. So that's level 1, 2, and 3. Not difficult. 1 and 2 is usually pretty easy. Level 3 gets a little complicated. So now let's go into how do we report all that. We talked about the procedures, we talked about the scope of the work. Now you have to report your work, right? So the standard will tell you very simply, for level 1, report all the level 1 information that we just went through a little while ago. Level 2, same thing. Just report all of the minimum requirements of the standard in your report, and you're good to go. And then finally, level 3, the same. In order to meet the minimum requirements of the standard, you just report all of those minimum requirements of the standard. Again, the standard is minimum requirements. You can do a whole lot more. But again, the minimum you have to report is what the standard asks you to do. So that's basically level 1, level 2, and level 3 energy audits. Very simple, very easy, right? Not a problem. Okay, now tough stuff, right? Now we throw some hardballs at you. Economic analysis. What engineer out there likes to do economic analysis? There are no hands. Well, we're going to explore some really easy ones and then get into like a complicated one, right? So, we always are trying to answer the question, is it worth it? Is it worth doing what it is you're suggesting? Because a lot of people have ideas, but customers are not going to do the ideas if you can't prove to them that what you want them to do is worth it, right? Would you do that at your house if it wasn't worth it? No, you would not, trust me. So, there are a lot of ways to do that. We'll just talk about a few of them, right? We'll go through the easy ones and then we'll end with a little harder one, right? So first up is simple payback, right? So simple payback's easy, right? You take the cost, divide it by the savings, and you get the amount of years it takes to pay back. Easy, simple. We do that all the time. It doesn't take, in effect, the time value of money and things like that, but our interest rates now are 1 and 2 and 3%, so interest rates doesn't really, cause us any trouble right now. If the interest rates were a lot more, then we would worry about it a little bit more, but we don't worry about it so much now. The next series of financial ideas I'm going to give you revolve around present work, okay? So, It is a popular method of valuation. Obviously, when you go into financing an energy conservation measure, somebody, an investor, the owner, somebody has got to decide they're going to put out the money, right? They're going to take out the money in order for you to do that. So, somebody has got to initially outlay the money or bring the money out front, and so that person wants to be assured that they're going to have a return on that investment, an ROI. Some way to know they're going to get their money back plus some in the future, right? So we use the present worth analysis to do that, and typically it's the project with the smallest present value that ends up being the right way or the best way to do things. Now, we're going to explore a lot of present worth, present value examples. Here's one. We take the formula, which is very simple, and we define the formula, simple. We're going to take this amount of money, $1,000, and look at it in 5 years at an interest rate of 10% and try to decide what we want to do, right? And so, if you are to receive the $1,000 in 5 years at 10%, what can you take today? Or what present value can you take today? So you do the math, really easy, and it comes out to $620. Makes sense. Yeah, if you do $620 today, put it in the bank, 10% interest, in 5 years it's worth $1,000. Very simple, very easy. Present worth works. It's very simple. Here's a little more complicated example. A constant volume HVAC system will be retrofitted with a new VAV system costing $100,000. You're saving 450,000 kW watts per year for a life of 10 years. Cost of electricity is $0.06 per kW. What is the present value, right? Is it a good project? So we do the math, right? We won't go through the math. We do the math. As it ends up, the project looks good because it's less than zero, which means it's a good project. Another good project. We've got 2 in a row now. So we can also analyze alternatives, looking at alternative A, B, C, D, and try to decide what to do there. We look at it in 2 different ways, mutually exclusive or as an independent project. Here's an example of that, right? We have 4 projects. Present worth $30,000. 12,500 minus 4,000 and 2,000. So, what are the good projects? Being mutually exclusive. Being mutually exclusive, the one we want is project A because it has the largest present worth. Then if we go to the independent projects, we're okay because we just want all the present worth values above zero. So now we can pick project A, B, and D because they're above zero, and of course C is a minus 4,000, so we don't want that. So that's another example of present worth. Another idea for present worth, if you're looking at alternatives that have the same equal life. Again, alternate brand X, brand Z, with its information. If you look at that, solve for it, the present worth that we're going to pick is Z because its present value is minus 45,000, which is more, or actually less than, minus 49,000. So that's why we picked that. Now the big one, right? Here comes the big one. The big one is life cycle cost analysis. Very detailed, not simple, and takes a lot of time and needs a lot of information. It is the way to go if you can find the time to do it, because it's very methodical and you have to find out a lot of information about the project, use that in your calculations, and eventually you'll come out with a sound life cycle cost analysis of how much that system, unit, building, whatever is going to cost over its useful life. And the way we do that is we look at the circle of a product of systems life. It starts off when you plan it, then you acquire it, then you operate it, maintain it, renew it, and finally you dispose of it, right? It's gone. And that's how you look at it. So I have an example for you, right? Two cars. So we have a Kia Soul and a Cooper Mini. We're going to look at that. We're going to look at all the costs. How much does it cost? What mileage does it get? How much does it cost for maintenance? What's the salvage value, et cetera, et cetera, et cetera. And at the end of the day, we have two numbers, right? The Kia Soul is $47,000 and the Cooper Mini is $53,000. What are we going to pick? We're going to pick the lowest, right? The lowest present worth. So that's the way it works with life cycle cost analysis, the same way, right? So it's the lowest present worth. It's also the lowest life cycle cost. It just dovetails or is the same as that mentality when you're doing it. So, not that difficult, right? But, it's something to think about. So what are EUIs? And how do we go out there and find those EUIs on a project? An EUI, or the Energy Use Index, also known as the Energy Use Intensity, is an approximation or an estimate of the total energy consumption of the building for the year. In the U.S., we talk about kBTUs per square foot. Here you would look at kW per square meter for the entire year. But there's a lot of different ways that we go out and try to find that. So we have to go out into the building. We have to look for those ideas, right? Where do we find them? We just simply have to walk around the building, right? Because the building is the doors, the windows, the outside enclosures, the roof, right? The HVAC and R system, electrical systems, power systems, all of those. All of those are ideas that you can use in order to come up with an energy conservation measure. This is a typical home. You can always look for that. And don't forget about hospitals. Hospitals are complex and they have a lot of complex systems, but that doesn't mean that they can't save a little energy when it's not affecting the health and care of their patients. So let's go out and look for some energy conservation ideas out there. There's a ton of them out there, right? So let's hit the simple ones, right? There's simple ones in photovoltaics, solar energy storage, renewables, all of that thing are ways in U4 to make and save energy for your building. Another easy one, temperature control. Always very simple. Electrical motors, variable frequency drives, internet and plug loads, lighting. We'll go through some of these, but there's all kinds of targets out there that you look at all the time and that you can go and take a look at in order to find ways to save energy for that building. In the U.S., we're doing a lot of whole building testing, so we're trying to figure out where all the holes are in the enclosure of the building so we're not air conditioning or heating the outside, unnecessarily, right? So we make the building tighter, we don't send that energy outside, we keep it. Ventilation, the current ASHRAE standards allow for us to reduce the ventilation loads in a building, so we can actually, if the building is like 10 or 15 years old, we can reevaluate that ventilation and exhaust per the current standards and actually save some money and still be doing the right thing, right? Controls, building automation systems, they are so easy to go through and find ways to save money. You've got temperature, humidity, pressure controls, right? Optimization, just calibrate the sensors. If they've been around for 2, 3, 4 years, they probably are so far out of calibration, they're 2, 3, 4 degrees off, 10% off RH, 50 off parts per minute. So just a simple calibration of sensors will really help you out. And then finally, we do a lot of carbon dioxide, CO2 optimization in the U.S. So if the CO2 in the building is not so bad, then we can modulate the requirements of the ventilation coming into that building. So, normally, in my practice, I can normally cut the CO2 30 or 40% of the day. Because people come in, they go, but as long as the ventilation systems are working good, that ventilation level is good, and so it stays good, and we can keep it. I told you we talk about lights, right? Lights have always been the low-hanging fruit for saving energy cost in a building. And they still are, right? You can still go out there and find those fluorescent lights that you can change. And if you want LEDs, you can change those lights either directly to LEDs or keep them as fluorescent. But either way, it works. Employ some day lighting ideas into your building. And finally, upgrade your controls. Add some lighting controls that actually turn off the lights when nobody's there, right? Or dimmer systems that let you use less energy when you don't need it. Because a lot of times you have openings to the outside in the daytime and you don't need so much light. So try to use that when you can. I want to share with you just for a couple minutes ASHRAE Standard 100, right? It is a great standard. It has a lot of ideas and a lot of things that you can use for energy conservation measure ideas. This is a copy of the face of the standard. And what I'm going to do is very quickly flash through a few pages of the standard. But this standard is so good, its Appendix E will give you 50 pages of ideas for energy conservation measures, and you never have to do any work, right? So for me, I use this all the time because I can't remember, 500 ideas, right? But here, the standard has all those cataloged, and you can use them. I'm flashing a few of them. There are so many for you to see there. So when you get a chance, you can buy ASHRAE Standard 100. You can get it online. You can get a PDF. And look at those ideas and see if you can make them work for your building. I guarantee you, for $69, the cost of the standard, you're going to save $69,000, right? So it's a no-brainer. You should think about getting the standard and giving it a try. Another thing I learned in my life is cleaning coils saves an incredible amount of money. I didn't know that. But my ASHRAE friend Bob Baker, back in 2006, he took me to New York with him. We retrofitted a large building coil. We cleaned that coil chemically, and we took the data before and after. We found out that we saved an incredible amount of energy. On that job in 2006, we saved 14% on the pressure drop across the coil. Obviously, pressure drop means fan power, fan energy, you save energy there. 25% increase in thermal efficiency, 10% increase in the latent heat, and all in all, a much better, comfortable building. But of course, Bob was the chemical manufacturer, and I was the control guy at the time, and so we did this project, for a lot of reasons, but also we did it to prove to people that it would work. But oftentimes in research, you need to have a third-party independent researcher go out and do things in order to prove it. So, in 2015, Dr. Bonfleff, who is a professor at Penn State University, also a past president of ASHRAE, him and his crew decided that, hey, I want to see if this really works. But Bill loves UVGI, right? He loves the ultraviolet germicidal side of things. So what he decided to do was do it using UVGCI instead of straight chemicals. So we went out there, we looked for the worst cooling coil we could find. We found it. It's shown here. Beautiful, beautiful coil. We retrofitted it with controls and all kinds of UV lights in the front and the back of the coil. Did a great job. Waited 1 year for all the data to work, and lo and behold, the data was very near to what we got in New York with the chemical treatment. Again, 12% decrease in DP, and a 14% increase on the temperature coefficient. That's incredible, just for cleaning a coil. So whether you want to clean it with chemicals or put a UVGC line light on it, do something, because it's all good, it all works, and it will really save your building some money. There are a whole lot of ideas that we can go through today. We went through a lot of them. There are so many more that we can talk about. Solar photovoltaic, solar thermal. You do a lot of that here. I see that a lot in Argentina. Wind power, not so much. Geothermal heat recovery, biomass. I see some biomass here. So there are all kinds of things that you are doing that works. So I would encourage you to continue to do that as time goes on. So with that, that's my technical talk. Now it's time for calculation. Who wants to do some calculation? I didn't think so. So let's do some quickies, right? So I told you in Florida, in my business, I do a lot of going back to buildings and reevaluating the ventilation rates that come into the building. So here's a very small air handling unit that if we recalculated the ventilation rate was 2,500 CFM, and it went from 25, well, it was 4,000, went to 25. So we had a small decrease, and with that small decrease, we were still able to save $262 a year. Now, that doesn't sound like much, I understand, but there's like 100 of these in the building. So a lot of these are very small, but if you take the very small number and multiply it times 100 or 500 or 50 or whatever, you can come to a good number, right? So we also went on the roof of that building and we found a couple monster outside air units, and we did the same thing. The original flow was 10,575. We went down from there and we were able to save 46, 44. We did the math, and we ended up with a great savings of $6,764 per year per unit. Now that's a big number. And that was 2 units, so we ended up saving $12,000, $13,000 in a couple of years. So you take all that, when you're doing your energy audits, you put it in an Excel spreadsheet, you document, what your costs are, what your paybacks are, what general information you did when you're doing that, and then you put it in a report. I could show you all kinds of samples of reports. You can go on the internet online and you can find a bunch of samples. Here's a couple headlines here, but everybody does their report a little different. But if you use the ASHRAE standard as a base, at least you're guaranteed to get the same information all the time. So with that, I want to thank you very much for letting me talk to you about energy audits, ASHRAE standards, and how they can benefit you in your professional life taking care of your building. Thank you very much.